In this lesson, we're going to look at some applications of logarithms, starting with exponential growth and decay questions, which you've likely seen in the past. So just to remind you, the formula for exponential growth and decay looks like this: y equals a times b to the x. And in that formula, y is the amount you end up with after x time periods. A is the initial amount, so what you start with. B is the growth or decay factor, which is calculated as either 1 plus the growth rate or 1 minus the decay rate, and x is the number of time periods. So for example, if we have an investment of $2,000, which earns 4.2% interest compounded annually, it says write an equation for A, the amount of the investment, after t years. So we're using A instead of y in this equation for our final amount. The investment starts at $2,000, so that's our initial amount. Now our B value is going to be calculated as 1 plus R, where R is our growth rate, or so in this case our interest rate. Now we need to change the 4.2% and write it as a decimal, so 0.042. So our B value is 1.042 in this question. So it'll be 2,000 times 1.042 to the exponent t. And then it says, how long will it take for the investment to double in value? So this is where logarithms are going to come in. So first of all, if our investment starts at 2,000, then it's going to double when it reaches 4,000. So we'll fill 4,000 in on the left side of the equation. Now, in order to solve this equation, we're first going to divide both sides by 2,000, which leaves us with the equation 2 equals 1.042 to the exponent t. Okay, now in order to solve for an exponent, this is where we need to use logarithms. So we're going to take the logarithm of both sides, and on the right-hand side we'll use the power law as well. So we'll write this as t log 1.042 all in one step. Then to get t by itself, we're going to divide both sides by log 1.042. So we end up with a t value of approximately 16.8. So therefore, it will take 16.8 years to double in value. Okay, the next type of example we're going to look at is dealing with the pH scale. So you may be familiar with the pH scale from science class. When we talk about pH, we're talking about the measure of acidity of a substance, so how acidic or alkaline a substance is. And the formula for calculating pH is given here in your note. So pH is equal to negative log H+, where H+ is the hydrogen ion concentration in a substance measured in moles per liter. So it says find the concentration of hydrogen ions in a substance that has a pH of 5. So if the pH is 5, we'll put that into the equation. And now to solve this equation, the first thing I would do is divide both sides by -1 to get that negative out from in front of your logarithm. And now remember, this is a base 10 logarithm. And so to write this in exponential form, we would say that the hydrogen ion concentration is 10 to the exponent -5, which is equal to 0.0001, which is found by moving the decimal 5 places to the left. So therefore, the hydrogen ion concentration is 0.0001 moles per liter. Okay. So another scale that we sometimes use logarithms with is the decibel scale. So the decibel scale refers to the intensity of sound. That's typically how we measure how loud something is. So in this formula, the B2 minus B1 is the difference in sound levels in decibels, and the I2 over I1 is the ratio of their sound intensities. So intensity here is measured in watts per square meter. So our example says the sound level of a whisper is 30 decibels and the sound level of normal conversation is 60 decibels. How many times as intense as a whisper is the sound of a normal conversation? So in this question, we're going to use this new formula. So B2 minus B1 equals 10 log I2 over I1. Okay, then we're going to replace our 2 decibel sound levels with the 2 in the question. So 60 minus 30, start with the larger one first, equals 10 log I2 over I1. So 30 equals 10 log I2 over I1. Divide both sides by 10. So 3 equals log I2 over I1. Switching that to exponential form, we have 10 to the exponent 3 equals I2 over I1, which means the ratio of intensities is 1,000. So that tells us normal conversation is 1,000 times as intense as a whisper in terms of the intensity of the sound. Okay, our second example says the sound level in normal city traffic is approximately 85 decibels, and the sound level while riding a snowmobile is about 32 times as intense. What is the sound level while riding a snowmobile in decibels? So in that case, we're going to replace B1 in the equation with 85, and we'll figure out what the other sound level is. So B2 minus 85 equals 10 log 32. And then in this case, we just have to add 85 to both sides. Okay, and then type that into your calculator, and that gives you an answer of 100. So therefore, the sound of a snowmobile measures about 100 decibels. Okay, and the last example we're going to look at is for the Richter scale. And the Richter scale measures the magnitude of an earthquake. And so the formula used for this one is given here, m equals log I over I naught, where I is the intensity, that should say of the earthquake being measured, and I naught with a little zero beside it is the intensity of a standard low-level earthquake, sort of our baseline. So how many times as intense as a standard earthquake is an earthquake measuring 2.4 on the Richter scale? So to figure that out, we're going to replace m in the formula with 2.4, and then we're going to solve for I over I naught. So when it says how many times as intense, it's kind of like that other question we answered. They're actually asking for that ratio. So writing this in exponential form, we write 10 to the exponent 2.4 equals I over I naught. And then with your calculator, evaluate that, and we get 251 sorry about the writing, 0.2. So therefore, an earthquake measuring 2.4 on the Richter scale is 251.2 times as intense as a standard earthquake, standard low-level earthquake. So for every increase in value on the Richter scale, there's a very, very large difference in the intensity of the earthquake. Next one, what is the magnitude of an earthquake 1,000 times as intense as a standard earthquake? So now in this case, we're going to replace the I over I naught with 1,000. So in this case, I over I naught equals 1,000. And then we're just going to solve. So in that case, log 1,000 equals 3. So therefore, the magnitude of the earthquake is 3. And that concludes this lesson.